Okay.
Yes.
Yes.
So let's get started. Okay.
Yes.
I hope my audio is clear. Okay. So today we'll be discussing sorting. Now, what exactly is sorting? See, as you can see in the diagram on your screen, sorting is nothing but arranging elements in a well-defined order. Now, this well-defined order is either ascending order or descending order, provided all the elements in your array are unique. That means if there is no repetition of elements, then what will happen is, okay, just so as I was saying, that sorting can be defined as the arrangement of elements in either ascending or descending order. Now, this is provided your elements are all unique. If there is no repetition of elements, the two well-defined sequences are either ascending order or descending order. So what happens in ascending order? The elements are strictly increasing. That means you won't find two consecutive elements to be the same. If you observe this array carefully, you will find that there are no two consecutive elements which are exactly the same. You won't find it, okay? Because the elements are strictly increasing. In ascending order, the elements are defined to be strictly increasing. Similarly, in descending order, you won't find any repetition of elements, and the elements are said to be strictly decreasing. That means you won't find any two consecutive elements which are exactly the same. And here we are dealing with arrays. So you when you define sorting, you would be defining it on a list. Now, a list can be of various types. In different programming languages, lists can be of various types. We will restrict our discussion to arrays in Java. So we will be defining sorting on arrays in Java. So I hope up to this point it's clear. You don't need to worry. I'll share this PowerPoint presentation with you. Okay, I'll email you the PPT. Next, what if elements are repeated in your array? It may happen that your array elements contain duplicate values. Then what? Then do you define ascending and descending order? No. When you have duplicate elements in your array, you cannot define ascending order or descending order. There what you do is you either define non-decreasing order or non-increasing order. These two, these two ordering of elements is defined when there are duplicates in your list, which in this case is your array. So if you find, like here you see that 2, the element 2 has been repeated twice, the element 1 has also been repeated twice. In such cases, you cannot define ascending or descending order. Why can you not define ascending or descending order? The reason being that in ascending order, the elements are strictly increasing. There'll be no two elements which are exactly the same. In decreasing order or in descending order rather, the elements are strictly decreasing. So you won't find any two consecutive elements to be the same. But in non-decreasing order, you can see that the elements are either increasing or remaining the same. See, here the elements are remaining the same. Again, here the elements are increasing. Again, remaining the same. Increasing, increasing, increasing. This is what you mean by non-decreasing order. Similarly, non-increasing order, the elements will either decrease, as you can see, from 7 to 6, from 6 to 5, the elements are decreasing, from 5 to 2, the elements are decreasing, but it can happen that the elements remain the same. That means after 2, you have another 2. After 2, you have another 1. So elements are decreasing, but again, after a 1, you have another 1. So elements are remaining the same. So this is what you mean by non-decreasing and non-increasing orders. Next, we will discuss two sorting algorithms. One is bubble sort and the other is selection sort. So what I'll do is I'll first explain the logic and then I'll move on to writing the code. So before moving on to bubble sort, I would take a pause. Okay. Now, how does bubble sort work? See, bubble sort is by far the easiest sorting algorithm to implement. It works by repeatedly swapping adjacent elements. Adjacent elements means elements which are present side by side. So bubble sort, what it will do is at every step, it will compare two consecutive elements, and depending on the ordering you're trying to implement, that means whether you're trying to implement ascending order or descending order, it will swap the elements. Okay, so like here, the example which I have taken, I have 5 elements in my array. As you can see, 5, 4, 3, 2, 1. Now I want to sort them in ascending order. See, these elements are already in descending order, so there is nothing much to do if you want to sort them in descending order. But if you want to sort them in ascending order, then you can see that the elements are not in place. So you will compare. So you compare 5 and 4. Now these two elements are out of order. Why? Because my elements have to be in increasing order. But 5 followed by 4 represents a decreasing sequence. So what will I do? I will swap them. So I'll swap 5 and 4 to get 4 and 5. Now next what I do is again I check the next two elements. So the next two elements are, as you can see, 5 and 3. Again they're out of order because if it has to be in ascending order, they have to be in increasing sequence, not in decreasing sequence. So 5 and 3 are out of order. So I swap them. So I swap and I get 3 and 5. Next again I compare 5 and 2. They're out of order. So I swap them. So I get 2 and 5. And finally I compare 5 and 1 to get 1 and 5, and see this constitutes the first pass. You'll understand what a pass is when I write down the program shortly. But for now, keep in mind that since I'll have to implement a nested loop in this case, the execution of one complete inner loop operation constitutes a pass. The execution of one complete operation of the inner loop constitutes one pass. So after pass 1, you can clearly see that the largest element in your array has been placed right at the end. See, the largest element in my array is 5. After the first pass is completed, 5 is at its right position. And remember, why is this name bubble sort? The name bubble sort stems from the fact that the elements are moving like a bubble from their current position to the position that they should be in. That means the current position of 5 is the first position in my array. So like a bubble, it will float, and one after the other, it will move to the last position, which also happens to be its correct position. Similarly, you will find that after 5 has been placed in its correct position, we will no longer check it. That's why I have, after pass 1, marked 5 with red, because after the first pass, I will not be concerned with 5. I will be considering the remaining elements. That means the elements which are preceding 5. See, which are the elements which are preceding 5 after pass 1? The elements which are preceding 5 after pass 1 are 4, 3, 2, and 1. So now I'll be concerned, I'll be writing my program in such a way that I'll have to deal with these 4 elements. I should not take 5 into account. So again, I'll compare 4 and 3. They're out of order. I'll swap them. I'll compare 4 and 2. Out of order. I'll swap them. Then I'll compare 4 and 1. They're out of order, and I'll swap them. So in this way, after second pass, the second largest element has moved to its correct position. Like a bubble, it has floated to its correct position. And same thing you can observe in pass 3 and pass 4, which are pretty self-explanatory from now onwards. So what I'll do is I'll just take a pause and continue shortly. So let's do this. Now, the first thing that I'll do is, okay, see, what I'll do here, you can do the same thing in BlueJ, okay, with minor changes. So let me write the program. After that, I'll tell you the changes that you need to make, okay? And once I've written the program, I'll keep on explaining as I write the code. I'll keep on explaining. And if you have doubts, then you can ask them after my program has been completely written, okay? So let's start. So let's begin, okay? Fine. Now I need to, okay, before I start typing the code, let me just save the file so that you can see the syntax highlighting. Okay. So I'm trying to implement bubble sort here. So I'll save it. Let me just save it. Just give me a moment. So I'll save it as type Java. Yeah. Okay. So first thing what I need to do is I need to import the scanner class. So import java.util.scanner. Now I'll have to define a class. Let's say the name of the class is bubble sort. And then I'll come to defining my main. Now here you will notice one minor difference. See here I'll write string args. You don't need to write this string args if you're implementing your program in BlueJ. Okay, just keep that in mind. That's the only change you need to make here. Otherwise, more or less everything remains the same. Now, first what I'll do is I'll create a scanner object which will help me to accept user input. So I'll say new scanner system dot in. And after I've created a scanner object, an object of class scanner, this is the object, scan is the object of class scanner. So after I've created the object, what I'll do is I'll first define an array. But before I move on to defining an array, I should declare the size. So now what I'll do is I'll first accept the size from the user. So what will I do? I'll prompt the user. I'll say, hello user, please enter the size of the array. So I'll say enter the, sorry about that, enter the size of the array. Now seeing this message, the user is smart. The user will go on to enter the size. So I'll store that value. So just let me write this scan dot next int. So what will I do is I'll store that value in this variable size. The value that the user enters for the size of the array will be stored in this variable size. Okay. Now after this, what should I do? I should go on to declare my array. And I should declare my array depending on the size that has been entered by the user. So I'll say int arr is same as, so I'll use the new operator and I'll allocate my array. So this will create, so this will create my, so this creates an array based on user input size. So up to this point, I guess it's clear. Now what will I do? Now I'll go on to accept inputs from the user. I need to fill up my array, right? Because if I don't fill up my array, I have nothing to sort. So first I need to fill up the array elements, and depending on the elements that the user enters, I will be sorting them. So what will I do? I'll simply prompt the user again. So I'll say system.out.println. I'll request the user that, okay, you please enter an element. Please enter an element. Now you can make this even better. Okay, let me make the listing clear, absolutely clear to the user. So I should say enter element. This will look better. You see, just observe now. Enter element at index, and then I should say plus I. So every time you see a message, you will have the index number displayed as well. That means the user will be prompted to enter the element at a particular index number. So first, initially the value of I will be 0. So the statement that will be printed is enter element at index followed by the value of I. What is the current value of I? 0. So it will be enter element at index 0. Then the value of I becomes 1. So it will print the message enter element at index 1. In that way, it's easier for the user to understand the elements which he or she is entering. Okay, it's easier to keep track. Okay, and after displaying the statement, I should accept the value that the user has enters. And where should I accept the value? I should accept the value entered by the user at ith position. So I should say arr of I. So initially the value of I will be 0. So I'll accept the value at position 0. Then the value of I will be 1. So I'll accept it at position 1. Then the value of I will be 2. Then I'll accept it at index 2 of the array. In this way, I will keep on accepting the array elements till I have reached the maximum size. So I should say arr of I is equal to scan dot next int. So this will give me the array elements. Now after I'm done with accepting input, so this loop that you see here, which I've just written, this will help me to accept input from the user. Now after I'm done with accepting input, I should move on to the sorting procedure. Now observe carefully, okay? So what I should do is I should start a loop. Now what will I do? I will start from index 0 and I will go up to size -1, because you see I'll be comparing adjacent elements, right? I'll show you why I'm saying size -1. See here, if you observe, see what am I doing? I'm comparing 5 and 4. Okay, sorry about that. I'm comparing initially 5 and 4, then I'm comparing 5 and 3, then I'm comparing 5 and 2, then I'm comparing 5 and 1. So I'm comparing two adjacent elements. So I'm comparing elements at indices 0 and 1, 1 and 2, 2 and 3, 3 and 4. When I'll reach the last position, that means when I'll reach the position where 1 is placed, when I'll reach this position which I've highlighted, then I do not have any elements to compare on its right side, because this is the last position. Now since this is the last position and I don't have any elements to compare on the right hand side, and I've already compared 1. When did I compare 1? When I was at this position, I compared 2 and 1. So 1 has already been compared. Now when I'm at position which is indicated by the element 1, then I have nothing to compare 1 with. There are no elements on the right side of 1, so I have nothing to compare 1 with. That's why I need to go up to size -1 position. I need to go up to size -1 position, so that I do not get any out of bounds index error. That means I should not cross the array boundary. When I'm at the second last position of my array, I am comparing it with the element at the last position. I'm comparing the elements at the second last position and the last position. Now, when I'm at the last position, there are no elements beyond it. So I have nothing to compare. That's why it's good enough if I go till size -1. And then what will I do? For every element, I will compare all the elements in my array. So I am at index 0. I am at index 0. Now I'll take the index 0 position and I'll keep on swapping. So for that, I need an inner loop. And for the inner loop, which will start from 0, I will go up to, mind you, size -I -1. Why is this size -I -1? This is done. This condition is implemented so that, I'll show you, so that after the first pass, you can see that the last element, which is 5, is placed at its correct position. So in order to enable me to skip comparing 5 from pass 2 onwards, I have to write this condition of n minus, or rather size -I -1, so that I am able to not compare the elements which are already in their correct position. In order to not compare the elements which are in their correct position, I will use this condition of size -I -1. Okay, this will help me to skip the elements, to skip comparing the elements which are already in their correct position. So I hope up to this point it's clear. Now what I'll do is I'll go on to write the swapping condition. So when will I swap? I will check if my two consecutive elements are out of order or not. I'm trying to do ascending ordering here. So I'll check which is my element at current position. The element at current position is denoted by the position of j, and the next element will be obviously at j plus 1. Now if these two elements are out of order, why will they be out of order? If my element at jth position is greater than my element at j plus 1th position, it means that they're out of order. And if they're out of order, what do I need to do? I need to swap them. So in order to swap them, what I'll do is I'll use a variable. Let me call it temp. So I guess all of you are familiar with swapping. We had done this in our initial classes. So I'll say temp is equal to ARR of J. Similarly, ARR of J is equal to ARR of J plus 1. And finally, ARR of J plus 1 is equal to temp. So this will enable me to swap my elements. Now what I want to do is I want to show you the output as well. So after I'm done with swapping, what should I do? I should now go on to displaying my sorted array. So how should I display my sorted array? I again have to run a loop. So what I'll do, I'll simply copy this. So I'll simply copy this loop statement and I'll paste it here. So I need to traverse the array and print the elements one after the other, right? So I should say system.out.print. And what am I trying to print? I'm trying to print the elements at the current position. The name of my array is ARR, and I'm trying to print the element at position I. And I should give some amount of space so that the output is easily understood. And before this, I should print out a statement. So I should print out a statement system.out.println that the sorted array is as follows, and I should go to the next line. So that in order to go to the next line, I have this \n. This will enable me to print the array from the next line onwards. So after printing this, I am done with writing my program. Now I'll save this and I'll show you the execution. Now before going to the execution, I'll just take a breather how this program can be executed. Okay. So I'll write java c bubble sort.java and it's compiling now. I hope I don't get any errors because otherwise again I'll have to go back. Okay, thankfully I don't have any errors in my program. Now let me execute it. So the name of the class which contains the main method is bubble sort. So I'll execute it. Now it's asking me for the size of the array. So let me take an array of size 5. Let me enter the element at index 0. Let's say the element at index 0 is 5. The element at index. So I'm entering the elements in reverse order. Okay. Now, as you can see, the sorted order of the array is shown to you. Okay. Now let me try another run. Let's say the size of the array is 5. Let me arrange the elements haphazardly. Okay. Let's say 3, 2, 5, 1, and 4. I still get the same result, right? 1, 2, 3, 4, 5. So my program is working fine. Now, let me just make one slight change to my code in order to make you understand the passes, the way actually bubble sort works. Okay, let me just make one slight change. So what I'll do is, so let the statement be here. Along with that, I'll display the elements at every pass. I'll display my array at every pass, then you'll be able to understand how bubble sort actually works. So what I'll do is after every execution of my inner loop, see, this is my inner loop, right? This is my inner loop. Now this inner loop constitutes a pass. That means one complete operation of the inner loop constitutes one complete pass. Okay. So what I want is I want to show you the contents of the array after every pass. So after this inner loop is done, I want to show you the contents of the array. So what I'll say is I'll just display this. So I'll just copy the statement so that I can make you understand which pass I'm talking about. So I'll say, I won't say the sorted array because after a particular pass, the array may or may not be sorted. So I'll say array after. So I'll say array after pass and then, okay, let me say array, yeah, after pass and then I'll append the value of j. And after appending the value of j, I will go to the next line so that the array can be printed on a separate line and it's easier for you to understand. So I'll just save this, and now I'll go on to the execution part. So let me try to show you how the array will work, how this program actually works. So let me just compile this. I hope I don't get any errors. Let's see. Okay, I have an error here. And what is the error? Okay, I have mistakenly reused the variable I. So I need to change that. So let me just change that. See, here the error that I got was because I'm using I once again, but already I is being used in this loop. I is being used in this loop and in the outermost loop. As you can see, this is the outer loop. The outer loop already depends on I, and inside my outer loop I have written a loop, this loop. Again, I have used the same variable. I can't do that. So let me just change that to K. I'll just change this to K. I can't use the same variable name in a block. See, this outer loop that you can see, yeah, this, as you can see by the highlighting, this outer loop constitutes one block. Inside this block, you cannot have two variables with the same name. I already have used I, so I cannot use I again here. That's why I've changed it to K. I'll save it and I'll try to show you the execution. Okay, so let me see. Now let me just compile this. So I'll say Java C. I hope I don't get any more errors. Okay, there's another error. Okay, I missed it. Okay. Now that was very careless on my part. I'll just make the changes. Just give me a moment. So I missed the K here. Yeah, I missed the variable K here. I guess otherwise everything looks good. I'll just save this and we'll go back to our execution environment. Now let's just try to compile this. Okay, now another error. Okay, I missed the K again. I'm being really sloppy here. I would apologize for being so sloppy. I was very sloppy on my part. So I should say after. So system.out.println after pass j. Now the problem here is I have declared j. I have declared j in this block. See, I've declared j in this block. Here j has been declared, so it won't be visible outside this block. It won't be visible outside the block which I've highlighted. So what I can do is I can simply declare j outside the loop. That way it will be easier for the program to understand that j can be visible outside the block as well. In fact, what I can do is instead of using j here, I can use the value of I. In that way it will be easier. Yeah, it will be easier. So I should say I. So in fact, I should say I plus 1 because currently the value of I will be 0. So I will be talking about pass 1. So it should be 0 plus 1, 1. Then when the value of I is 1, I'll be talking about pass 2. So it should be I plus 1, 1 plus 1, 2 in that way. Okay. Now let's see. Let's go back. Now let's try to compile this. Okay, now where is the problem? Now variable j has already been defined. Okay, let's see, where did I go wrong? Did I remove? Okay, I forgot to remove the declaration here. Okay, now let me save this and let me go back to the execution part. So I'll just erase all this. Okay, I'll just clear the screen and now let me compile this. Thankfully I don't have any errors anymore. Now let me run this. Let's say the size of the array is 5 and I'm entering random elements 10, 12, 1, 7, 4. Now you can see the array after every pass. So array after pass 1 is this. See, after the pass 1, see the elements which I entered. How many elements I entered? I entered 5 elements. Out of these 5 elements that you see, which is the highest element? 12. So as you can see, after pass 1, array after pass 1, see 12 is at its right position. The highest element has moved to the last position. Then array after pass 2, please pardon the formatting. This array after pass 2 should be on the second line. I have to include one new line character. Otherwise, I think it's clear. So array after pass 2 is this. So after the pass 2, you can see that the second highest element, which is 10, has moved to its correct position. Then after pass 3, the third highest element, which is 7, has moved to its correct position. After pass 4, the fourth highest element has moved to its correct position. And finally, the sorted array is as you can see here. Okay. So I hope you have understood this. What I'll do is I'll move on to the next sorting method.